Right now, we're living through a resurgence in space games and space simulation. More studios than ever are promising high-detailed environments and high-detailed game worlds, often physics-driven universes. These are galaxies, places, worlds that you can explore for many hours, where every location feels authentic. But for us as players, the real question isn't just how big the map is, but whether the systems governing that map actually create meaningful, unscripted gameplay. So what you're seeing on the screen right here is Space Engine. It's a dedicated universe simulator and one of the most remarkable scientific visualization space tools ever built. But it also highlights the scale of the challenge, because building a galaxy that looks convincing is not the only hard part. Another hard part, perhaps the hardest, is building a galaxy that holds together when you actually play in it, where the systems underneath generate environments you can feel. And this is a problem that was solved over a decade ago. There was a single game that simulated 400 billion star systems from first principles of astrophysics, not from art direction, not from random noise, but from actual physics, such as mass, chemistry, gravity, and time. And it did this so accurately that it predicted the existence of a real star system before NASA even discovered it. Now, if these are the type of videos that interest you and you haven't done so already, please do consider subscribing, because it really helps this channel, and it certainly helps videos like this reach the people who are most interested in hearing them. So yeah, whatever your views are on the current state of Elite Dangerous, this isn't a video about the game's direction, but this is about design philosophy, and it's one that proved something fundamental about how we build game worlds that players actually want to exist in. So most procedural generation in space games works like, well, it works a little like decoration actually. You define the rules about what can and can't exist, you have random noise within them, and you get variety. That means you can land on 1,000 planets or a few dozen planets depending on the game, and they'll all to some degree look different. But from a games player point of view, this does have some inherent problems. For example, a frozen world orbiting a red dwarf looks about the same as one orbiting a blue giant, because the generation never asked why that world is frozen in the first place. It just rolled the dice and moved on. And as a player, you can definitely feel that. I know I can. The galaxy then stops surprising you because there's no underlying logic to discover. Many games out there have had different approaches to this problem. No Man's Sky, for example, chose artistic freedom, and on the other hand, Star Citizen chose a handcrafted fidelity. Both of these ideas are valid, but neither attempts to let physics decide what can and can't exist. And this really matters if you're in a game for the simulation and the complexity. And this is where Stellar Forge comes in. This is the system behind Elite Dangerous. It started from a completely different premise. It began with the estimated mass of the entire Milky Way, and then distributed that across three-dimensional space using real astronomical data. And this came from things such as known stars from scientific catalogues, and these were placed as anchors in the correct places. Everything else was then generated to account for mass that should exist but hasn't already been directly observed. Now, when you jump into a star system in Elite Dangerous, the Stellar Forge system generates it from scratch on your machine and on the servers as well, I guess, using nothing but the galactic coordinates as a seed. And it does this from real-world science, real-world physics. We'll get to the details on that in just a moment. But here's what this approach actually produces for the player. A lot of people like to think that is scale, but really it's not, because scale in itself isn't overly hard to do. What Elite succeeds in is coherence. When you land on a moon, for example, in a binary star system, that moon's composition, its terrain, and its orbital position are all the consequences of how that system formed. And honestly, you really can feel this as a player when you're navigating through the galaxy. You might not realize it, but it's perhaps one of those subconscious things that just adds to the realism. And if you do notice it, then it'll be even more important to you. And for me, this really is the gap between a game world that can impress and one that can convince. These are two very different things. And if you're after complexity and the simulation, then you're really looking for something that both convinces you and impresses you. And what this actually does deliver. It's why this galaxy still feels worth exploring after more than a decade. And it's not the planets that are more beautiful, or even though they have been upgraded over the years, it's more to do with the fact that they make sense, and that this consistency is something that you can feel as a player, even if you can't necessarily name it directly and explain why it feels like it does. Now, if you want proof that this approach produces something fundamentally different, something that works, there's one story that makes the case better than any technical breakdown. Back in 2017, NASA announced the discovery of TRAPPIST-1. This was a dim red dwarf with 7 terrestrial planets, roughly 40 light-years from Earth. But before anyone knew this system even existed, the Stellar Forge system inside Elite Dangerous had already generated a nearly identical one in almost the same location. A slightly smaller star, 7 terrestrial worlds 39 light-years away, and even generated moons and binary pairs that NASA's methods couldn't yet detect. So the Stellar Forge distributes mass based on what physics predicts should exist, and there was unaccounted mass in that region. The simulation did what the real universe did. It formed a small star with rocky planets from the available material, and when Frontier updated the game with NASA's data, it required only a minor tweak. The simulation had already done the real work. And here's the thing, that's not procedural generation in the typical games industry sense, not how we normally mean it. This is actually modelling, and it's a standard the current wave of space games should perhaps be measured against. It's not all about visual fidelity, it's not about the planetary count. You could do this with much smaller planets, you could do it in a single star system even. It all comes down to whether the place you're playing in, the environment you're in, actually behaves like one should. That said, it is important to point out that Stellar Forge isn't perfect, and pretending otherwise would undermine this entire argument. The system was built on data from around 2013. Since then, we've learned that Earth-like planets are more common than it predicted. Real systems are far messier, hot Jupiters, orbital migration, chaotic orbits that the system doesn't fully model. And the system is essentially locked now. Changing the algorithm would risk altering the entire generated galaxy. There's only so much you can actually change before you collapse things. But either way, this still proves that the philosophy was right, even if the data itself was originally incomplete or perhaps a little bit too simple. Now, there is something we can take away from all of this. I'm not just going in here with a game engine review talking about why Stellar Forge or Elite Dangerous are so good or so bad or whatever else. There is an underlying point here that I really want to convey to you. And it's where the current moment becomes really interesting, because many studios out there are promising the next step in space game fidelity. And these are facing many of the exact same challenges, whether or not they want big, complicated environments or whether they want smaller environments. The idea here is, do you simulate from first principles or do you decorate with procedural variety? At this point in time, I think we all know the pros and cons of both. Elite Dangerous certainly has a lot of pros when it comes to galaxy generation, and then we have No Man's Sky with its variety, more artistic-led galaxy, which also has a lot of pros, but it also has a lot of cons. It seems to me that a next-generation version of this approach could model planetary migration, atmospheric retention, and other preconditions for biological activity. Imagine perhaps a game where the simulation knows whether a planet could hold an atmosphere. Again, this doesn't have to be at a galaxy level, it could be at a single star system level or just a few dozen star systems. It could then work out whether this planet and this environment could support life. And then imagine what that means for exploration in your gameplay. This isn't just about creating a galaxy, it's about the impact it has on the games itself. What would this have on trade routes? What would it mean for players who choose to build in a specific environment? Because it would mean you're no longer doing these things in just random ad hoc environments. You're doing them in locations that feel genuinely real. So Stellar Forge really did prove that when you let physics lead, the universe does a lot of the creative work for you. You can connect to binary stars, you can co-orbit gas giants and drone stable moons. You can impact histories that are written into planetary surfaces themselves. And these are all outcomes that no designer could actually spend huge amounts of time needed to do them. In many cases, they're probably outcomes that no designer would even imagine. So the future trick, I think, is to learn from all the games that are currently out there. We've got No Man's Sky, we've got Star Citizen, we've got Elite Dangerous as well, and we know which of these work and which of them don't. We know what aspects of each game actually works and which don't. And I think this leads us to a question for the genre as a whole. We've all got a pretty clear idea now what works in terms of galaxy generation. The real question is, how do you hang genuine quality gameplay on top of all this? Because each different idea here, each different generation of how you create your galaxy or your game world really does dictate and determine what type of game world and what type of gameplay you create. And for me, that is all about coherence. And what I mean by coherence is both the world that makes sense, the universe that you design, as well as the gameplay that inhabits it. We know now that one of these can be solved by trusting to physics instead of just pure design, that by accepting the real universe is more creative than any team of artists. We saw all of this in Stellar Forge, and we see it to some extent in the Space Engine as well, perhaps to a greater extent. And we know all of this can be expanded upon. And when games could finally get to the point where they can generate environments and galaxies like this and attach it to real, grounded, solid gameplay, then we're going to have a universe that doesn't just look stunning, but also is really worth visiting. Let me know what matters to you more in space games. Universe that's visually stunning, or one where everything you find has a real reason to exist. Looking forward to reading your comments. Do check out the other video in the screen right here. Thanks for watching this one. Do take care, and I'll catch you next time.